Europe is embarking on a bold experiment, creating entire islands from scratch in the middle of the sea to generate enough renewable energy to power millions of homes. These aren't ordinary islands. They are purpose-built platforms designed to host massive offshore wind farms, solar arrays, and energy storage systems, all integrated into a single engineering marvel. The ambition behind these artificial islands is staggering: to provide a reliable, scalable source of clean energy while advancing Europe's climate goals and reducing reliance on fossil fuels. The stakes extend beyond energy supply. Success would establish Europe as a global leader in renewable innovation, influence international energy markets, and provide a blueprint for countries around the world seeking large-scale, sustainable energy solutions. The concept is already in motion, with Europe's first artificial energy islands planned in the North Sea, a region known for strong, consistent winds and ideal conditions for offshore wind power. Countries leading the initiative include Denmark, the Netherlands, and Germany, each with ambitious projects to construct islands that can host tens of gigawatts of wind capacity. Some islands are still in the planning phase, while pilot projects are under construction, testing modular designs, anchoring systems, and energy transmission technologies. These islands will connect to the mainland via subsea cables, distributing power efficiently to multiple countries. Globally, their significance cannot be overstated. If successful, these artificial islands will serve as a model for large-scale renewable energy production, demonstrating how nations can harness natural forces at unprecedented scale to meet climate and energy needs while minimizing land use conflicts. The decision to build artificial islands for energy generation stems from space limitations and efficiency challenges on shore. Europe's coastal countries have limited land suitable for large-scale solar or wind farms, and building massive renewable energy projects inland often faces environmental, social, and logistical hurdles. By moving offshore, engineers can tap into open seas with strong, consistent winds, allowing turbines to operate at maximum efficiency almost year-round. The North Sea, in particular, offers shallow waters and predictable wind patterns, making it ideal for massive wind farms and energy islands that can produce gigawatts of electricity reliably. Artificial islands also allow for integration of multiple renewable technologies in one location. These islands aren't just wind farms. They can host solar panels, hydrogen production facilities, energy storage systems, and control centers, creating centralized hubs that combine generation, storage, and distribution. This reduces the need for separate infrastructure and allows energy to be transmitted efficiently to multiple countries via high-voltage subsea cables. In essence, artificial islands transform the sea into a scalable, flexible, and highly productive energy platform, demonstrating a level of ambition and technological integration that would be difficult to achieve on land. Beyond efficiency, these islands offer resilience and modularity. Islands can be expanded or upgraded over time as technology improves or energy demand grows, unlike fixed onshore sites constrained by urban development or environmental protections. By building artificial islands, Europe is creating a future-proof, scalable solution to energy supply that addresses not only current demand, but also decades of projected growth in renewable energy consumption. Constructing artificial energy islands is a massive engineering challenge that pushes the boundaries of modern technology. These islands must withstand harsh offshore conditions, including strong winds, high waves, and saltwater corrosion, all while supporting enormous structures like wind turbines, solar panels, and energy storage facilities. Engineers use modular designs, building sections of the island onshore or nearby, and then assembling them at sea. Foundations are carefully anchored to the seabed, often using a combination of piles, concrete platforms, or floating structures, depending on water depth and seabed conditions. In addition to structural challenges, energy transmission is a key engineering hurdle. Electricity generated offshore must be transported hundreds of kilometers to the mainland through subsea high-voltage cables, which must minimize energy loss and withstand pressure, currents, and potential interference from shipping and marine activity. Advanced monitoring and control systems are required to manage energy flow from multiple sources: wind, solar, and storage, while ensuring stable delivery to national grids. Some islands are also being designed with hydrogen production facilities, converting surplus renewable electricity into green hydrogen for storage or export. This requires integrating electrolysis units, pipelines, and storage tanks into the island's layout without compromising safety or efficiency. The scale and complexity of these islands make them not just energy platforms, but floating cities of technology, where precision engineering, renewable energy integration, and maritime construction intersect in a way that has never been done before on such a large scale. Artificial energy islands offer significant environmental advantages by providing massive renewable energy production without taking up valuable land on shore. By moving wind farms and solar panels to the open sea, Europe can reduce its reliance on fossil fuels, cutting greenhouse gas emissions and helping meet ambitious climate targets. The islands also minimize land use conflicts, preserving agricultural areas, forests, and urban spaces for other essential activities. Some projects are even being designed with marine ecosystem integration in mind, where foundations act as artificial reefs, supporting biodiversity and helping fish populations thrive. From a strategic perspective, these islands enhance Europe's energy security and independence. By producing vast amounts of clean electricity offshore, countries can reduce reliance on imported fossil fuels, shielding themselves from volatile global energy markets and geopolitical disruptions. The islands can serve multiple nations through interconnected grids, creating a shared energy infrastructure that fosters regional cooperation while maximizing efficiency. Furthermore, Europe's leadership in constructing artificial energy islands positions it as a global pioneer in renewable energy technology, showcasing engineering, innovation, and climate responsibility that could inspire similar projects worldwide. These environmental and strategic benefits make artificial islands more than just energy producers. They are symbols of Europe's commitment to sustainability, innovation, and long-term resilience, offering a scalable solution to climate change while strengthening the continent's geopolitical and economic standing in the global energy landscape. The construction of artificial energy islands promises significant economic benefits for Europe. Building and maintaining these massive offshore structures will create thousands of jobs in engineering, construction, operations, and technology development. Local economies in coastal regions will benefit from infrastructure investment, while industries related to renewable energy, maritime logistics, and advanced manufacturing are likely to see growth. Additionally, the island's ability to generate tens of gigawatts of electricity opens up opportunities for industrial expansion, as reliable, clean power becomes available for energy-intensive sectors. Socially, the islands could influence urban and community life indirectly. By providing abundant renewable energy, they contribute to lower energy costs and reduced pollution, improving living conditions across the continent. Furthermore, the projects can foster educational and technological hubs, inspiring innovation and research in renewable energy and marine engineering. There may be challenges too, such as potential impacts on shipping routes, fisheries, and tourism, but careful planning and regulation can mitigate these effects. Overall, artificial energy islands are poised to stimulate economies, create jobs, and drive social and technological advancement, making them a transformative force beyond their primary role as energy producers. Europe's artificial energy islands are already moving from concept to reality, with several pilot projects under construction in the North Sea. Denmark is leading the way, planning islands capable of hosting up to 10 gigawatts of offshore wind capacity, while the Netherlands and Germany have announced ambitious projects to expand the network in the coming decade. These islands are being built in phases, starting with smaller modular platforms to test construction techniques, energy integration, and subsea cable connectivity. Lessons learned from these early stages will inform larger-scale expansions, with the ultimate goal of creating interconnected energy hubs capable of supplying electricity to multiple countries simultaneously. Long-term plans include scaling these artificial islands into a network that can collectively provide enough renewable energy to power tens of millions of homes, effectively forming the backbone of Europe's future energy grid. International collaboration is central to these efforts, with investment coming from national governments, energy companies, and research institutions. Technological innovations, such as hybrid wind-solar systems, hydrogen production, and energy storage, are expected to be integrated as the islands expand. If successful, These projects will demonstrate the feasibility of offshore renewable megastructures, offering a replicable model for other regions seeking to combine energy production, climate action, and technological innovation on a massive scale. Europe's artificial energy islands represent a bold vision of how the continent plans to power itself sustainably while leading the world in renewable energy innovation. By turning the open sea into a hub of wind, solar, and storage technology, these projects could provide electricity to millions of homes, reduce carbon emissions, and secure Europe's energy independence. They demonstrate that with enough ambition, engineering skill, and international cooperation, humanity can rethink traditional energy infrastructure and harness natural forces at an unprecedented scale. Yet the islands also raise crucial questions. Can these structures withstand the harsh offshore environment over decades? Will the subsea grids and energy storage systems operate reliably across borders? How will environmental, economic, and social challenges be managed as the islands grow in size and number? Ultimately, Europe's artificial energy islands are more than just renewable energy projects. They are a glimpse into the future of engineering, climate strategy, and international cooperation, showing what is possible when vision meets technology on a massive scale.